The purpose of this video is to help you understand in a little more detail how the solutions are derived for the practice final. In the first problem, we want to find the domain of this function. To do that, we understand that the domain of a function is all x values where the function is defined. So look along the x-axis and see where it traverses. We can see that it's the open interval from -2 to 3. State the domain of the following function. The domain of a rational function is all real numbers except where the denominator is 0. The only number that causes division by 0 for this function is x = 5. So the domain then is the open interval from -∞ to 5 union with the interval from 5 to infinity. State the domain of this function. This is a radical function, a square root in particular, so the radicand cannot be negative. This means that we need 4 minus x squared to be greater than or equal to 0. So we'll solve this for x. Factoring, we have two cases to consider. Either both factors are positive or both factors are negative. In case 1, we see when we solve for x that -2 to 2, the closed interval, is the domain. Case 2, we get x is less than or equal to -2 and greater than or equal to 2. That's not possible. So we know that the domain is the closed interval from -2 to 2. Use this graph to find the limit of g of x as x approaches 0. Notice the function value at x = 0 is -2. However, the left and right-hand limits at 0 are both -3, so that would be our limit in this case. Evaluate the following limit. The limit is 2x squared minus x plus 5 as x approaches -1. Because this is a polynomial, we can simply use direct substitution to find the limit. So we simply evaluate the polynomial when x is equal to 1, and in that case we see the value is 8. Evaluate the following function. We have a rational function and we're taking the limit as x approaches 3. This causes division by 0, so we can't use direct substitution. The approach here is to factor the numerator and simplify. When we do that, we cancel out the common factor of x minus 3 and we're left with x minus 5. In that case, now we can use direct substitution to get that the limit is -2. Determine the following limit. This is a limit as x approaches infinity of 1 plus 2x over x. When we take limits at infinity, we look at the dominating factors, and in this case, it's the term with the highest degree in the numerator divided by the term with the highest degree in the denominator. If we look at that ratio, that's simply 2. Determine the following limit. The limit as x approaches infinity of negative cosine x over x to the 4th plus 1. The numerator is constant in the sense that there are no real values of x that are going to cause it to be anything different than just a single numerical value. It oscillates between -1 and 1. The denominator gets extremely large for large values of x, so the limit here is 0. Find the derivative of f of x is equal to -3x squared plus 19x minus 14. So we simply use the power rule and addition rules to get that f prime of x is equal to -6x plus 19. Find the derivative of f of x is equal to negative 2 times the square root of x plus 3x to the fifth minus 10. Simply apply various rules of derivatives, and in the simplified form we get negative 1 over the square root of x plus 15x to the fourth. This is a point in the video where I would encourage you to pause and make sure you can match my calculations. Find g prime of 1 given that g of x is x squared divided by 2x minus 7. Applying the quotient rule, we take the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. Simplifying this, we get 2x squared minus 14x divided by the square of 2x minus 7. Finding g prime of 1, we see when we substitute 1 for x, g prime of 1 is negative 12 over 25. Find the derivative of 2x to the fourth times cosine x. Using the product rule, we take the derivative of 2x to the fourth, then multiply by the cosine of x, and then we add to that 2x to the fourth times the derivative of cosine x. In the simplified form, we have 8x cubed times cosine x minus 2x to the fourth sine x. Find the derivative of the tangent of 2x cubed. Applying the chain rule, we get the secant squared of 2x cubed times the derivative of 2x cubed, which is 6x squared. A boat is drawn close to a dock by pulling in the rope at a constant rate. True or false? The closer the boat gets to the dock, the faster it's moving. This is true because the rope is being pulled at a constant rate. The closer the boat gets to the dock, the faster it's moving. The reason for this, notice as the boat gets closer to the dock, that slope of the line between the boat and the dock gets steeper, which indicates that it's moving at a faster rate. True or false? If f of x is continuous on a closed interval, then it's enough to look at the points where f prime of x is equal to 0 in order to find its absolute maxima and absolute minima. This is false because we know by the extreme value theorem we have to test the endpoints also. Imagine you shoot an arrow into the air. What's the shape of its shape? What shape is the graph of its speed as a function of time from the time you release the arrow to the time it achieved terminal velocity? The path of the arrow looks like this. So the shape of the graph of its speed as a function of time is decreasing and concave down. The figure below shows the area of regions bounded by the graph of f and the x-axis. Evaluate this from 0 to b. By the fundamental theorem of calculus, we can split this into the integral from 0 to a plus the integral from a to b. The integral from 0 to a is 14, and the integral from a to b is negative 8. So the resulting total area, or net area, is 6. Evaluate the following integral, the integral from 3 to 7 of x squared plus 4 dx. Simply use the reverse power rule to get this is x cubed over 3 plus 4x evaluated from 3 to 7. Evaluating this at 7 minus the value at 3, we get 364 divided by 3. Evaluate the integral from 1 to 5 of 3 over x squared dx. Again, reverse power rule, if we think of this in terms of 3 times x to the negative 2, then we get negative 3 over x evaluated from 1 to 5, and the end result is 12/5. Evaluate the integral from negative 3 pi halves to 3 pi halves of 2 sine x dx. When we integrate sine x, we get cosine x. Negative cosine x, excuse me. So the integral is negative 2 cosine x from negative 3 pi halves to 3 pi halves. Evaluating those at those two values, we get the end result is 0. Consider two functions f and g on the closed interval 1 to 8, such that the integral from 1 to 8 of f of x is 15, the integral from 1 to 8 of g of x is 7, and the integral from 6 to 8 of f is 7, and the integral from 1 to 6 of g of x is 3. We want to know what's the integral from 6 to 8 of g of x minus f of x. Step 1, we would apply properties of integrals, and in this case we have the integral from 6 to 8 of g of x minus the integral from 6 to 8 of f of x. In the second step, the integral from 6 to 8 of g of x is the integral from 1 to 8 of g of x minus the integral from 1 to 6 of g of x. And we see that this is 4. The last step then is to take 4 minus 7 to get the total integral is negative 3. Express the area of the shaded region as the sum of two integrals with respect to y. Do not evaluate the integral. Because we're integrating with respect to y, we need to solve each of the equations given in the graph for x. So we have y is equal to 8 minus x on the interval from 0 to 3 implies that x is equal to 8 minus y for y in the interval from 5 to 8. Doing the same thing for the second equation, we have x is equal to y minus 2 for y in the interval from 2 to 5. And as we can see then, we split this up into 2. We have the integral from 2 to 5 of y minus 2 dy plus the integral from 5 to 8 of 8 minus y dy. Determine the arc length. If we were to determine the arc length of y equal 4x plus 3 on the interval from 0 to 4, which of the following is the simplified form of the integral that we would use? Using the formula for arc length, we have the integral from 0 to 4 of 1 plus the square of the derivative. The derivative of y is 4, so we have the square root of 1 plus 4 squared, or the square root of 17. In the figure below, the equation of the parabola is y equal x squared minus 22. The equation of the dashed line is y equal 21x. Determine the area of the shaded region. First, we have to find the points of intersection to determine our limits of integration. We simply do this by setting them equal to each other. Because it's a quadratic, we set that equal to 0 and factor. Our two limits of integration are negative 1 and 22. Because the line lies above the parabola, we'll take 21x minus the equation for the parabola. Replacing everything with negative 1 and 22 and using our formula for calculating this, we get that this is 12,167 divided by 6. Again, this is a rather lengthy calculation, so I would encourage you to pause the video and check that you can get to the same answer as I have. Compute the derivative of f of x is equal to 13 times the natural log of 4x. Simply apply the chain rule here. The derivative of the natural log of 4x is 1 over 4x. Multiply that by the derivative of 4x, which is 4, and then our constant 3. The simplified form is 13 over x. Find the derivative of f of x is equal to the natural log of e to the 2x plus 7, evaluated at x is equal to the natural log of 3. Again, applying the chain rule, we get the derivative is 2 times e to the 2x divided by e to the 2x plus 7. Evaluating this at the natural log of 3, we're using properties of exponential functions and logarithms, and the fact that they are the inverse of each other, to get this as 18 over 16, or in the simplified form, 9 over 8. Evaluate the following integral. 1/3 times the integral from 0 to the natural log of 11 of e to the x. The integral of e to the x is simply e to the x. Applying the limits of integration, we get 1/3 times 11 minus 1. The key here is remember that e to the 0, or any non-zero number raised to the 0 power, is always 1. Don't mistake this to be 0. So the result here is 10/3. Determine the domain of the natural log of x plus 1. We know that the domain of the natural log of x is the open interval from 0 to infinity. The domain of the natural log of x plus 1, based on transformations, is the domain of the natural log of x shifted left 1 unit. So the domain here would be the open interval from -1 to infinity. Determine the range of e to the x minus 3. We know the range of e to the x is 0 to infinity, the open interval. The range of e to the x minus 3 is the range of e to the x shifted down 3 units. So the range in this case would be the open interval from -3 to infinity. Evaluate the integral from 1 to e to the 4th of 6 over x dx. The integral of 1 over x is the natural log of the absolute value of x. In this case, our limits of integration are positive, so we can ignore the absolute value. Evaluated at e to the 4th and 1, we get 6 times the natural log of e to the 4th minus 1, which is 6 times 4 minus the natural log of 1. Natural log of 1 is 0, so the result is 24. What change of variables would be used for the integral of 15 minus 2x to the -3rd dx? We always use the innermost function, which in this case is 15 minus 2x. What's the best choice for dv when evaluating the integral x to the 7th times e to the 4x dx? The two functions are to consider as possibilities are x to the 7th and e to the 4x, along with the differential dx, because remember dv is a derivative. In other words, we can eliminate choices A and D. They don't include the differential. Since e to the 4x is easier to integrate, that would be our choice for dv. So B would be the selection for this problem. A ball is launched vertically upward from a rooftop 448 feet above the ground at a speed of 48 feet per second. Its height above the ground t seconds after the launch is given by S of t is equal to -16t squared plus 48t plus 448 for t between 0 and 7. When does the stone reach its maximum height? In order to determine this, we have to find the derivative. The derivative is negative 32t plus 48. Now set this equal to 0 and solve for t. It's important to point out that we would also test the endpoints in this case. It turns out those are not any bigger, in fact smaller, than when t is equal to 1.5. Suppose a fishing guide has a boat that holds a maximum of 86 people. Assume his profit in dollars for taking n people on a fishing trip is P of n is equal to n times the quantity 4 minus 0.5n minus 86. How many people should the guide take on a fishing trip to maximize profit? Again, because we're trying to maximize, we're going to take the derivative. This is 43 minus n. Setting this equal to 0 and solving for n, we get that n is 43. Remember, we would test the endpoints as well. Our domain in this particular function is 0 to 86. If you test each of those values, 43 will result in the maximum. Find the area of the surface generated when y is equal to the square root of negative x squared plus 10x minus 21 on the interval 4, 5 is revolved around the x-axis. This is a rather lengthy problem, so you may at times want to pause the video to make sure your calculations agree with mine. So first we want to find the derivative, dy. In this case, in its simplified form, we have negative x plus 5 divided by the square root of negative x squared plus 10x minus 21. Now let's work on the pieces needed for the surface area, in particular ds. That's the square root of 1 plus the square of the derivative. This gives us the square root of 1 plus negative x plus 5 squared divided by negative x squared plus 10x minus 21. Don't bother doing anything with the denominator, but what we do want to get is get a common denominator. And when we do this, our next phase of the calculation would look like this. Now expand out the negative x plus 5 squared and combine like terms. We end up with the square root of 4 divided by negative x squared plus 10x minus 21. Simplified, that would be 2 over the square root of negative x squared plus 10x minus 21. Now for the surface area. The formula for that is the integral, in this case from 4 to 5, of 2 pi y ds. So we simply plug in what we have for y and what we have for ds, simplify it down. It looks ugly at first, but it simplifies down nicely. And the end result is 4 pi. Evaluate the following integral using integration by parts. Let's let u of x be 7x and dv be cosine x dx. Then du is 7 dx and v is sine x. Using integration by parts, we have 7x sine x evaluated from 0 to pi minus the integral from 0 to pi of 7 sine x dx. Evaluating at these integration limits, the end result is negative 14. Evaluate the integral from negative 7 to 0 dx over the square root of 9 minus x. Using rules of integration, we get this as negative 2 times the square root of 9 minus x, evaluated from negative 7 to 0. Once we simplify that, the end result is 2. Evaluate the following integral. In this case, I would recommend factoring the denominator. We want the integral from 1 to 6 of 2 over the square of x plus 2 dx. In this case, then, we can simply use the reverse power rule to get negative 2 over x plus 2 evaluated from 1 to 6, and this is simply 5/12.